Hello, this recording is for Pre-Algebra Chapter 4, Lesson 6, Rational Numbers. But first a quote from Lemony Snicket, Bitter true as you can. Avoid horseradish, page 62. This one's a weird one, I warn you. Wishing, like sipping a glass of punch or pulling aside a bearskin rug in order to access a hidden trapdoor in the floor, is merely a quiet way to spend one's time before the candles are extinguished on one's birthday cake. Yeah, I have no idea what that means. All right, rational numbers. I do know what those mean, though. A rational number is any number that can be written as a quotient, fraction, or ratio. Whole numbers and integers are also rational numbers because they can be written as a fraction. So if I say, what is 2 as a fraction? Well, that would be 2 over 1. What is negative 3 as a fraction? Well, that's negative 3 over 1. Just as I said, any whole number or integer can be written as a fraction. You could also write negative 3 as negative 6 over 2, because if you simplify it, you still get negative 3. Got it? Okay, so here are 3 ways to write a negative rational number. For each rational number, there's an unlimited number of equivalent fractions. Just like here, I had negative 3 can be written as negative 3 over 1, which equals negative 6 over 2. Which equals like negative 18 over 3. There's a ton of ways you can write them, and it's just your job to find them when asked. Okay, so here's one way you can write a negative rational number. All right, with the negative sign like in line with the fraction bar. Okay, but negative 7 over 9 is the same as negative 7 over 9, which is the same as 7 over negative 9. They're all the same. They're all negative, they all represent the same fraction. So even though they look slightly different, they're all the same. And this is going to become very important when you have to do graphing in chapter 3, or in 3 chapters, not chapter 3, because that would have been last chapter, but around chapter 7, you guys are going to have to do some insane graphing. And this idea, the negative sign can be in several different places and still be the same thing, will be very important. Okay, so equivalent fractions, rational numbers, there you go. All right, so let's go ahead and write 3 equivalent fractions for negative 4/5. Well, you could use the trick that I used earlier, which is just putting the negative in a different spot. That's equivalent, and that's equivalent. But let's go ahead and do it where we've got some other stuff as well. So I can multiply 4 and 5 by the same number and get no equivalent fraction. So if I multiplied by 2, on the top on the bottom, that's going to give me 8 over 10, negative 8 over 10. Because equivalents still need to have the same sign, either negative or positive. So we could even multiply by 3, negative 4/5 times 3 over 3, and that's going to give me 12, it's a 12 over negative 15. All right, so there's a bunch of equivalent fractions there. I've got one there, got one there, I've got one there, and I've got one there. There we go. So I definitely gave you more than 3. All right. Here we go. All right, so let's go ahead and graph these numbers on a number line. We have negative 1/2, negative 4/10, negative 2, and 0.9. So the first one we're going to graph is negative 1/2. So we got to find the halfway point between 0 and negative 1. Right there, halfway point. Bada bing, bada boom. Beautiful. All right. Now we need negative 4/10, which means we need to break up the distance between 0 and negative 1 into 10 parts. Well, I know that the halfway point, negative 1/2, is the same equivalent of negative 5/10, right there. So then if I break up between 0 and negative 5/10 into 5 parts, I will also be able to then find negative 4/10, which is right there. Beautiful. All right, and then negative 2, well, it's already on there, so there it is again. And then positive 0.9. Well, the halfway point between 0 and 1 is 0.5, right? Decimals, 0.5 means half. So then if I break the distance up between 0.5 and 0.1 into 5 parts, because there's 5 parts on the other side between 0 and 0.5, the last one before 1 is going to be 0.9. So there you go. Now let's go ahead and list these from greatest to least to greatest using inequalities. And least to greatest means that we're going to look at the number line and go from left to right. So the first number that we had from left to right was negative 2. The next one was negative a half. And so negative 2 is less than negative 1/2. Negative 1/2 is less than negative 4/10. And negative 4/10 is less than, 0.9, because we only had 4 of them there. That's right. 0.5, not something we actually had to graph, but I used it to help me graph. Okay, so there you go. You going from least to greatest using inequalities. And then if they asked you to go from greatest to least, you'd go from the right side to the left side of the number line. And you just need to make sure you have your inequalities going in the correct direction. Okay, last thing we need to talk about today is fraction bars. Huge, ginormous fraction bars that have usually an operation on the top or an operation on the bottom or both. All right, so when you have a big giant fraction bar and you're following the order of operations, the fraction bars act as a grouping symbol where you need to simplify the top and the bottom before dividing. It's very important. Do not try to divide before you've simplified the top into one number and the bottom down into one number before doing that division. Even though you know division comes before adding and subtracting in order of operations, you now need to treat this huge, ginormous fraction bars as a grouping symbol, and grouping symbols even come before exponents. Okay, so you got to remember your please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. Where these is where the P is normally parentheses, but we're just going to be general and call it grouping symbols. Okay, so that's why the fraction bar, you got to simplify the top and the bottom before you take care of it. Okay, all right, so since we have some variables in there and I tell you what the variables are, we're going to replace the variables with the numbers before we do any math. So A is 6 and B is negative 5. So if I replace A with 6 and B with negative 5, we're going to get 6 plus negative 5 over 3. Well, 6 plus 5 is 1. 1 over 3 is 1/3, and that's as simple as it gets. We just got to remember we got to write in simplest form. So you will have to reduce a few fractions today, but just remember to reduce the fractions like we did in, what was that, lesson 3? Lesson 3 of chapter 4? Let me look that up real quick. Yeah. Oh no, lesson 4 of chapter 4. So if you need a reminder about how to simplify fractions, go watch that video again. Okay, so second problem, we have 7 minus b over 3 times a. So I'm going to replace b and a, and so I'm going to get 7 minus negative 5, 7 minus negative 5, and remember, when you're replacing a letter with a number, put the number in parentheses where the letter was. So b was negative 5, so negative 5 is now in parentheses. Not because the parentheses mean much, but sometimes they can really play the difference. So here it doesn't mean anything, but later on it might. So let's go ahead and add the opposite. And 7 plus 5 is 12. 3 times 6 is 18. This fraction is not in simplest form, so I'm going to write it out as a prime factorization. Cancel out some stuff and get my simplified fraction. And I already started problem number 3. There we go. Oh, there we go. Okay, so 12 over 18 equals 2/3 once you simplify it. And now we're ready to go on to the next problem. I'm going to replace a with 6. 6 plus 9 over b. B is negative 5. 6 plus 9 is 15. 15 over negative 5 is negative 3. And that's as simplified as it gets. All right, guys, I am done. Have a good rest of your day. Bye.